So we're going to take a quick look at maximizing area and minimizing perimeter in rectangles. This is just to make the most effective use of materials. So in the case of maximizing area, what we're looking at is we're given a specific perimeter. We have this much material. What's the largest area we can enclose with that material? So if we look at this, what we're going to do is we have this a rectangle with a perimeter of 20. We got a length and a width that we need to figure out what are the ideal length and width to get the biggest area. So the length and the width, well, there's two lengths and two widths. So half of this perimeter from here to here is the length and the width. So the length plus the width should equal 10. And we can put whatever units we want in here. I'm just avoiding that to keep it a little cleaner. So the length plus the width should equal 10. So we need to take this table here and we're going to pick pairs of numbers that add up to 10. So we got 1 and 9, we got 2 and 8, we got 3 and 7, we got 4 and 6, we got 5 and 5, 6 and 4, 7 and 3, and you notice it's just going to continue with the same pattern going backwards, so we'd have the same pair of numbers. So it's somewhere within this top set here that we're going to find our maximized area. So if we go through this and take a look, area is just length times width, so we have 9, we have 16, we have 21, we have 24, and we have 25. And then again the numbers would just continue 24, 21, 16, and 9 in reverse on the way down. So our maximum area is at 25. So the rectangle with the maximum area happens to actually be a square. And in any given case, our rectangle with the maximum area is always going to be a square. So if you can create a square to maximize the area, then that's what your dimension will be set at. So now, similar to finding the maximum area, we want to also be able to minimize perimeter at times. So if we have to enclose a certain area of space, we want to use the least possible amount of material to enclose the outside. So to find the minimum perimeter, let's change that to smallest. That's the smallest possible perimeter. And then we're looking at trying to minimize this distance around the outside, so we got to find that length, that width again. In this case, I'm giving you an area of 36. So around this rectangle, the length times the width is 36. So we just need pairs of lengths and widths that will multiply to 36. So we could do 1 and 36, we could do 2 and 18, 3 and 12, 4 and 9. 5 doesn't work with a whole number. There's a decimal there, so we're going to skip that one and just go 6 and 6. Then we can continue with 7 and such that will be decimals, but what will end up happening is we're going to just reverse this table here, so we'll have 9, 12, 18, 36, and then it'll be all reversed. So it's the same pairs of numbers. So now we take these numbers, we multiply them out to find and add them up to find the perimeter. So perimeter is 2 lengths plus 2 widths, or length plus width times 2. So 1 plus 36 times 2, and that is going to give us 74. 2 plus 18 times 2 is going to give us 40. 3 plus 12 is going to give us 15, times 2 is going to give us 30. 4 plus 9 is going to give us 13 times 2, which is 26. We're going to skip the 5 again. 6 plus 6 is going to give us 12 times 2, which is going to give us 24. And so you see these numbers are continually going down until we get to 6 by 6, and then it reverses again and would continue up is 26, 30, 40, 74 as the numbers went back up on this side. So here we have our minimized perimeter for this area. So the smallest perimeter is also found in a square. So you can maximize area and minimize perimeter of a rectangle by creating a square. And how do you do that? Well, the square root of the area is going to give you that answer. So the square root of 36 is 6. That will be the dimensions of the minimum perimeter. So you can do any number. If you had an area of 47, then you would just take the square root of 47 and you would get about 6.9 or so. And you can get even decimal numbers as well. But you're just taking the square root of that area to find the dimensions that will minimize perimeter.